All right, and these ones, again, we've already been doing most of this. So this video is just kind of giving you some extra context, some extra practice, some extra tie-ins on these ones. I don't think there's anything going to be new in this video. All right, so let's start with example 5. Solve algebraically and verify graphically. We've been doing this already. 100 tangent squared of x plus 20 tangent of x minus 3. We got another quadratic on our hands. All right. So we're going to say let x equal the tangent of theta. Or sorry, oops, we have an x twice. Can't use x for both of this. Let y equal the tangent of x. This gives us 100y squared plus 20y minus 3. AC method, we're really hoping it factors. Are there two numbers that multiply to negative 300? That's a times c. That add up to positive 20? Ooh, I don't know. 1 and 300, that's way too far apart. 2 and 150, 3 and 100, still far apart. 4 and 75, 5 and 60, we're getting closer. This is 55. This adds up to 55. 6 and 50, closer. 7, no. 8, no. 9, no. 10. Negative 10 and 30. Oh, okay, good, good. These numbers multiply to negative 300 and add to positive 20. So again, we're going to factor by grouping. This gives us 100y squared minus 10y plus 30y minus 3 equals 0. Factor by grouping. 10y times 10y minus 1 plus 3 times 10y minus 1 equals 0. Factor out a 10y minus 1 from both of them. We're left with 10y plus 3. And then you could solve these to get that y is equal to positive 1/10 and negative 3/10. So tangent is 1/10 and negative 3/10. Now it's really nice in these cases when we can throw out one of these equations because there's no answer. Unfortunately for you, the range of tangent is all real numbers. So that'll never happen with tangent. Tangent can equal anything. We have to solve these. All right, but we can't solve these exactly, right? We need to approximate. When is tangent of x equal to 1/10? There's no special triangle for that. We're going to do it like we did before. So there's going to be two answers, right? It's equal to positive. It's positive something. We're going to have one answer that we'll get from inverse tangent, and then a second answer. What happens if we add pi? Okay, so 1x is going to be inverse tangent or arctan of 1/10. What is the inverse tangent of 1/10? It's about 0.0996, 0.0997. And you could convert this to degrees, or you could remember that tangent is pi periodic. So the answer in the first quadrant and the third quadrant are just going to be pi apart. So we could just add pi to this. We don't have to draw a really good picture. And you get 3.2413 radians. Again, you can also convert this to degrees and use the same methods we did in 953 with the quadratics. Pause the video, try to use the same process, this other equation. One of these x's is going to be the inverse tan of negative 3/10, and the other is just going to be pi, different from that. So if we type that in, arctangent negative 3/10. That's going to be negative 0.2915. Uh-oh. Why is this a problem? Why am I uh-ohing? Oh. It didn't specify. I wanted the problem to ask for all the answers in 0 to 2 pi. Wait, this is not in 0 to 2 pi. But we can make it in 0 to 2 pi, right? What this is right here, this is a negative angle. So we can get an answer in the interval 0 to 2 pi if we just add 2 pi. And that'll give us to this positive angle. Okay. So we're going to add 2 pi to get this blue angle. That's going to be another answer that we're going to write over here. So let's add 2 pi to this. About 5.9917. radians. And then our last answer is going to be what happens if we add pi to this. Just like before, if it's negative, tangent's either in one of these two quadrants. So we already found the one in the fourth quadrant. We add pi, we'll get to the one in the third quadrant because tangent's pi periodic. The period of tangent is pi. So we just add pi to get to the other one. That'll be 2.8501. And again, it's best if you write these in order, but I'm not requiring it. You can leave your final answer like this. Let's verify graphically. Right? So we're looking at 100 tangent squared of x plus 20 tangent of x minus 3. We're asking when is that equal to 0 on the interval from 0 to 2 pi? Well, around 0.1, 2.85, and 3. Uh-oh. I typed things down wrong? Or did we, something happened? Right? Our answers are not lining up. 2.85, we have that. 3.24, we have that. Oh, this is 0.1. This is 0.1 right there. They rounded. And the other one is actually a little off your screen. Oops, that's the wrong button. The other one is a little off your screen. Let me, there you go. The other one's 5.9. Whoa. 5.992. Okay, good. So we actually do have the right answers. You just had to round. Whew, I got a little scared there for a second. And that's kind of what you can do with these ones. All right. Let's do example 6. Approximate with a calculator on the interval from 0 to 2 pi. Part A, sine of x equals negative 0.90. This would have been better to do before the last example, but here we are. So again, we're looking for all the answers. So we're going to start by finding one answer. And then just like we did in the quadratic video, just like we did in the earlier problem, we're going to have to do some tricks to find the other answers. So there's probably going to be two answers here. One answer is x equals the inverse sine of negative 0.90. What is that? Inverse sine or arc sine of negative 0.90 radians. And again, these are usually easiest if you convert them to degrees. So multiply by pi, 180 over pi. This is giving us negative 64.1581. Again, just like that tangent example, this is giving us something it's not in the interval. That just has to do with the range of inverse sine. Remember that? The range of inverse sine was negative pi over 2 to positive pi over 2. We have to find coterminal angles. This is giving us an angle of about negative 60 degrees. But it's no problem, right? Finding the interval, the angle from 0 to 2 pi. That's just going to be 2 pi plus negative 64.1581. All right. So that's no problem. And then we're also looking at, whoa. What other angle are we looking at? What two angles are sine negative in? We're looking at the fourth quadrant, which is that red angle, and the third quadrant. So we need something in the third quadrant with the same reference angle. This right here, whoa, it doesn't look like the same reference angle. We have the same reference angle. That's going to be pi plus that 64.1581. Those are our two answers here. Oh dear, not pi. We're using degrees. 360 degrees. Not pi. We're going to do 180 degrees right here. All right, so type those into a calculator. That should get your answers. X is approximately equal to 360 minus that angle. I'm going to write plus because it's a negative already. 295.8419 degrees is our first one. And the second one is 180 plus this angle, or about 115.8419. These are our approximate angles in degrees. All right, and if you check your answer with Desmos, just be careful to convert these to radians or convert Desmos to degrees. All right. Let's do, do I want to do a fun one? Part B. 4 sine squared of x plus the sine of 2x times the secant of x minus 3. We actually can't calculate this one exactly. We're missing some identities. I didn't cover the double angle identity for this class. All right. So the only way we're approximating with this with a calculator is using Desmos. So this one's actually going to be a little easier. The left-hand side, let's type it in. 4 sine squared of x plus the sine of 2x times the secant of x minus 3. When is that equal to 0 on this interval? Right here. We're done. Approximate using a calculator, you said it. We're done. X is going to be 0.709. And 2.432. There we go. Good idea to make this little note. So as I'm grading, I know how you got your answer. But yeah, if it's telling us to use our calculator, feel free to use Desmos. And that's this video. Good luck.